Okay, so this class will be about data. So what's data and why do we need it? You have an idea for a stock strategy or any type of financial model, and you will have to test if it worked. And the only way to test if it works is to test it against historical data. So what we need to do is to get historical stock data from the internet. So essentially, historical data is just a table with dates and prices. So for each date in the past, we're going to have the stock price and more important information about the stock for that particular date. So there are many ways to get this information from the internet, some of them free. We are going to learn about Yahoo Finance. It's a very popular library in Python that scraps stock historical prices from Yahoo Finance website. And we're going to learn about a paid service, and the one we chose is Polygon.io, which is not very expensive and provide excellent historical data. So to do that, we are going to use something called REST API, but don't worry, Python take care of all of this. Essentially, it just means that you send a request as a URL for the data you are interested in, and you get a response with all the data. So let's get a bit deeper and see how this data look like. Usually when you look at a stock graph like this one, you see for each point we have a date and we have a price. So for example, on the 7th of October, we had a price of 380, and let's say on the 12th of October, we had a different price. But during those days, there were many prices for the stock, right? We didn't have only a single stock price of 380, right? So let's zoom in into this particular date, 7th of October, and see what's going on inside that day. So looking at a stock graph for this particular date, 7th of October, we can see that the stock market every day opened at 9:30 a.m. and closed at 4 p.m., right? And during this period of time, the stock price changes a lot. So we are going to choose only 4 values from this day to represent that particular day. We're going to choose the open price at 9:30 a.m., the close price at 4 p.m., and we're going to choose the high price, which is the highest price during this period of time, during this day, and the low price, which is the lowest price during this particular day. So in this case, when we said that the price on the 7th was 380, we mean that it was the close price of the day, 380. Usually when we use Python to get this historical data, we are going to get the data as a table that looks something like this. We will have date, open, low, high, and close. And for each date, for example, here, 7th of October, we will have all these 4 values. So the close was 380 in this example, and let's say the highest was 386 and the low 379. Let's say the open was also 379. And for each date of the dates period that we ask, we are going to get these 4 values: open, low, high, and close. So in Python, this table is going to be represented by something called a data frame. So we have a library in Python called pandas. Pandas is a library that have an object that called data frame. Data frame essentially is just a table, but it allows you to store huge amounts of data and manipulate them in a very efficient way. Okay, so let's make some money and write code. Okay, so this is our project. We have here 3 files currently: main.py, class1.py, this is where we handle our program, and api.py, which is the module to get data from the internet. We start in the main by importing class 1. Class 1 is this current class. And in class 1, we are managing this project. So here we import API. This is the module to get data. We will build it later. Next, we import the pandas. This is what we talked about, that the library that allows us to handle data frames, and we import datetime. Of course, you have to install those with pipe install pandas if you haven't yet. Next, we define 2 dates here. So those dates are the dates period that we are interested to get data from the API. Next, we take these two strings dates and we turn them to be Python dates objects, because it's better to work with objects. And here we create this data frame, this table that we just talked about, and we use the API function that we will write very soon. It's called get underline y, which means get underline y finance. We are using here y finance to get this free historical data. So we provide the ticker, which stock we're interested in, SPY, and we provide arguments as date 1 and date 2. This is the period, and the interval. Like we want to get daily data, so the interval here is 1 day. So let's build this API module. Let's be the first function to get underlying historical data from Y Finance. So this is the function we are going to program. And first we have to import some stuff. So first we import the pandas, as we just said. We're going to also import the Y Finance library. This is the library that allows you to get free historical data. You have to install it first, don't forget, with pipe install Y Finance. And we are going to use these three other libraries: import request, which allow us to do HTTP requests, the datetime, and PYTZ, just a dates library to manipulate date time zones. So we start with Y Finance. This is the API that allows us to get free stock data. So as we said, this function is going to get few arguments: the ticker, date 1 start date, date 2 end date, and interval of the data. So we take these two dates that we receive as argument and we turn them to be strings, because this API requires strings. Next, we create a ticker object, which is a Y Finance object, and we give it the ticker that we just received here as an argument. So we will create a ticker object, and next we can do many things with this object. Once we create this ticker object, we want to get the data. So here, data equals spy.history. We take this spy ticker object and we use the function history, and we provide the start and the end dates and the time interval for our data that we want. Okay, so let's run this and see what happens. So you can see we get the table as we want it, with this column open, high, low, close, but the table have some problem. First, you can see that the date is not a normal column like the rest of the columns. It's the index column. So instead of having a normal index 0, 1, 2, 3, 4, 5, they put the date as an index, and we are not interested in this. So let's go back and change it. First, let's reset the index. When we reset the index, we move the date from being an index to be a normal column. And now the index will just turn to be numbers from 0 and up until n. So 0, 1, 2, 3, 4, 5, etc. Next, we want to rename the column names, because the names currently have capital first letter. So date with big D will be small d, and open will turn to be open with small o, etc. So we do this for each column that we want to change. We provide this dictionary into the data, to the data frame, and we will rename it. So we will get the new names. And next, after we rename the columns, we want to remove the time zone, because we don't need time zone. We just need the normal date for every day with the month, year, day, hour, minute, etc. So we will use the PD to datetime function, and here you can see that we give it the format that we're interested in. So Y mean year, M month, D date, and then hour, minute, and second. This is how we want the date to look like. So we turned this date column to look like this. Next, we want to keep only these columns. We don't need the rest of the columns that they give us. We just need the date, open, low, high, close, and volume. That's what we talked about in the sketchbook, right? So now let's print this data and see how it looks. Let's move this print from here to down here and print the result and see how the new data frame looks like. Okay, so let's run this, see what happened. So this is the data frame, but you can see that we cannot see everything. Some of the columns are hidden. So in order to clarify this, let's do data to string, which will print the whole data frame as a string, not as an object, and we can see it better. There you go. This is our data frame now. So you can see that we have here date column, open, low, high, close, and volume. This is the column we discussed in the sketchboard before. And we see here that for every date, for each date of the period that we asked the API, we get these 4 values. So 3 of October, 4 of October, etc. Okay, so you can see here in the comment, small comment here, that 1 minute data is only available for the last 7 days, which means if you want to get data with like zoomed in data, right, like with 1 minute interval between the data points, you can only do it for the past 7 days. But what if you want historical data for 2, 3, 4, 5 years, and you want it to have a high resolution? You want to have 1 minute data, not daily data. So to do that, you have to use some paid services, and we actually need to do that because to create more serious strategies, we need more resolution. So we will learn now how to use the Polygon API to get data with higher resolution. So let's get deeper into this function that we write here, get underlying. We will get the historical data using the Polygon API. And we have 2 small functions here. Request, use the request library to make HTTP request, and this small function just handle time zones. So to request data from the API with Polygon, we are going to work with what we said called REST API. Essentially, it means that we need to build this URL and send it to the service to get back data. So this URL, we'll go over it later, but essentially what we have here is we need to provide the ticker name that we want to get. It could be 1 ticker or a few. We need to provide the resolution, as we said here, with 1 minute resolution. And we need to provide the date period, which is the start date and the end date of our data. So if you look here, you can see that the dates that this API require, we have to provide them as numbers, because Polygon work with dates as numbers, which is the representation of the milliseconds passed since some year in the past. And here we have to provide some other metadata, most of it not very important, but we will go over it later. The important stuff here is that how you want to sort the information from earlier to later, or the opposite, limit, which how many data points you're interested to get, and the API key. Of course, you need to have an API key, which you can get for free on the website to start working with it. So let's look at this function. It gets a few arguments: the ticker, the start and the end dates for the period, the unit, which is the resolution that we're interested in, and the interval. So 1 minute will be 1 minute resolution. It could be 1 day resolution, or 1 year, etc. The Polygon key is the key that you can get on the website. You then take the 2 dates that we give the function, dates object, and as we showed, we have to turn these dates into numbers, because that's what the API work with. So essentially what we're doing here is to take a date and turn it to be a huge number that represents the milliseconds that pass since the year 970, because that's how Polygon work. Then we start to build this URL. So first we build the base, the period, the meta, and we construct the whole URL. Let's go over it quickly. So the base is this string, the beginning, which is the endpoint of this URL, and we provided the ticker. You can see that this part. So we create this part, and we provided the ticker that we get from as an argument to the function, and then the range, right? We use here the unit and the interval arguments that we receive, and the start and the end date. It's this part of the URL. This is the period. Next, the meta, right, which include a few fields here, but the most important one is the polygon key. So we have to provide our polygon key for the API. So we head over to the Polygon website under the documentation, and we can see that we have this endpoint called aggregate bars. And here you can run an example request to see how it looks. So let's go over it quickly to see what fields we have to provide the API. So we have the SPY, this is the ticker field. And the next two fields are the resolution. So in this case, multiplier is 1 and time span is day. So it could be 1 day or 5 day or 1 week. You can play with that and get whatever you want. So here, instead of day, for example, you could set it to be minutes, second, hour, week, etc. So it's pretty powerful. Next, from and to, those are the start and the end dates of this request. Let's run this and see the result. This is the result that we get from Polygon. So this is a dictionary and it have many keys. You can see the ticker that we request, how many results, but the important key is the results. The results key in this dictionary is a list, as you can see here, a list or array, in other words, of dictionaries. So each dictionary in the list is a single data point, which is a data point for a single date. Right? So if you look at the keys inside this dictionary, you see V for volume, volume weighted, open, close, high, low, and T is the time of the date of this data point, and it represented as a number, if you remember we said. So what we're going to do is to take this results key, and we're going to loop over all the items and create a data frame from them. We're going to loop over it to do it in order to understand it better. So we have an infinite loop here until we stop it. And in each iteration, we're going to do request URL. URL is the URL we just created right here. And request is the function that we define here. And we provided the URL string, and we are using the request library, Python library that will make for us the HTTP REST API request. And it will return the response as a JSON. A JSON essentially is a dictionary that comes as a string. So at this point, R will store the results from the API. Now we say history equals R at results. We take the results key, and if you remember, the results key is this one. In the response, the results key represent all the data points as a list. So we will take this list from the results key and store it in history. So now we will create a new list to store our dictionaries. It will be an empty list called ticker samples, and we are going to take this response of dictionary list and change it a bit. So we're going to for over this results list and manipulate it. So we will create, for each data point, create a new dictionary. So first we'll take the date here, and it's represented as a number as we just showed, and we will take it and turn it to be a normal date. Next, we will manipulate the time zone using this function that we just showed. So remember this function, but you don't have to do it, so it's not important to get into it now. Next, we will change the column names. So you can see they call it C for close, O for open. So we change each one of them to have full name: date, close, open, high, low, and volume. So once we manipulate each dictionary here, we add it to our own list of dictionaries, as you can see here. And later we can take this list and turn it to be a data frame. And this is what we actually doing in the next line here. So we will say ticker data frame equal PD concat. Concat mean to append. So we will append or add this new list of dictionary into our empty data frame. Now, since we might not get all the results at once, we are going to ask here if we have a key called next URL. Next URL is a key that Polygon provide you if there is more information for you to have, because they cannot send all the information at once. So if we have this key with next URL, we are going to take this URL that they give us, we're going to add the Polygon key, the API key that we have, and we're going to make a new request with this URL. So this while loop will happen again if we have a URL with more data. It's called pagination. If we don't have, we will break the loop and keep going with the code. Next, we ask if the unit equals day. So if we ask a resolution of 1 day from the function, we want to remove the time element from the day. We do it by doing .dt.date here. And if you remember when we received the result previously, we have this, you see, time element that we don't need. So next, we are going to run this function get underline that we just programmed. So let's add here the unit equals day. We want daily information here, right? And let's print the results and run this function to see how it looks like. So there we go. We get our data frame. There it is. So you can see we have 238 rows here, which represent around a year of data. And this is the date column. So for each date, you can see that we have those values that we just showed before. So for example, for this date, we have the close price, the open price, the high, low, and the volume. And this is daily information. In the same way, we could get information with a 1 minute resolution or even less. Once we have this huge data frame, we can do a lot of cool stuff with it that we are going to see in the next classes.